we all think in a certain way. And I think that way is not necessarily problem-oriented. A lot of people think about engineers as liking problems. We eat them for lunch, we sometimes say, but that they're solution-oriented. They see a need and they get excited when they can actually find a solution that works. And that is the passion, I think, that engineering training gave us, and engineering discipline allows us to succeed in the world, no matter what we're doing. As engineers, we're looked at to be able to give recommendations to someone who's a client who is usually not an expert in engineering. So then what we want to be able to do is to be able to not necessarily argue, but to inform them on what our findings are and then interpret what that means to the customer. So after we do some analysis with let's say the chair, right, that we've determined that the design, the sleek design that the customer wanted, and they wanted it to be made of wood, this sleek design is not going to work with any wood that's available. Then we always say, don't show a problem without showing a solution. And so we ran other tests, you would say, and with this other material that we tend to know works, we did a quick design and test, and we found out that we can make that design even sleeker. And it could look like this. We always present the final choice to the customer because there's usually a trade-off. And what we have to show them is what that trade-off is. Sometimes in terms of aesthetics, sometimes it's in terms of performance. In the case it will look beautiful and it will break. The minute you have someone who is 150 pounds sitting on it, or a kid who jumps on it. Story goes that early when skyscrapers were being done, they had elevators. And the customer, the owner of the skyscraper said, "These elevators are going too slowly." And the engineer said, "Oh, really? Okay." And they said they tried to make them faster. So they made them a little bit faster. And the customer came back and said, "These elevators are still going too slowly." And so then they asked the question a different way, more database. They said, "Well, how fast should they be going?" Well, people want to be able to have the elevator, they press the button and it comes, within this period of time. Well, elevators, it depends on who's coming up, where it's coming from, and so forth. And even ideally, if that happened, the engineers calculated and said, well, this is going to create all sorts of neck problems. People will have fears of senses of vertigo. They'll get compressed, and it'll be like a roller coaster. It won't be like an elevator. And they're like, what makes you think it needs to go faster? Because they knew they couldn't solve that problem. And the customer said, well, because they press the button and they're bored. They don't know what to do. And the other engineers are like, it's not the speed, it's the perception of speed. So the solution of the problem was to put mirrors on each floor. And then all the complaints for slow elevators went away, because apparently people like to look at themselves and they don't know how much time goes by until the elevator came. And so that's what they did.